In this video, we'll use SPSS to evaluate some of the research hypotheses drawn from Hutton's 1953 sightseeing experiment that's described in the chapter titled Design and Analysis of Experimental Research 1. The data for this example can be found in the file Miksza and Elpus Sightseeing Intervention-t-test. First, we'll conduct an independent samples t-test to determine if there's a statistically significant difference between the mean post-test sightseeing scores of the treatment and control groups. We're using an independent samples t-test in this case because the means we're comparing come from two different groups of people who we are assuming have not been matched or paired in any particular way. So to do this, we'll go to the Analyze menu to compare means, down to independent samples t-test. We'll enter in our test variable, the sightseeing post-test scores, and our grouping variable, whether the participants are in the control or experimental group here. And SPSS would also like us to define which particular categories of this grouping variable we want to compare. And we only have two here. In this case, we have zeros, which stand for the control group, and we have ones, which stand for the experimental treatment. And we click OK. And so we get two bits of information here in our output window. First, a summary of the descriptive statistics for the various groups. We see that there are 20 people in each group, control and treatment. The mean post-test sightseeing score of 11 in control and 22 roughly in treatment, standard deviations for each, and the standard errors of their means. And we could use this to create confidence intervals if we'd like. Before giving us the formal t-test result, we first have a test of the assumption of equal variances between groups. And as in the case of many tests of statistical assumptions, we want this test to reveal a non-significant finding and to tell us that we have met our assumption. So in this case, with a p-value or a sig value of 0.923, we can rest assured that we do not need to reject the hypothesis that the variances are equal. So that allows us just to go on and look at the t-value, the degrees of freedom, and the significance value, the p-value that comes along with the comparisons of means test here, the t-test. And since this is below the threshold of 0.05, though admittedly just below that threshold, we would say that there is a statistically significant difference between these means. In other words, we would reject the null hypothesis of no difference. And then SPSS by default also will compute the mean difference here for us, give us a standard error statistic for the mean difference, and build a 95% confidence interval for that difference. Next, let's conduct a dependent samples t-test to determine whether there is a statistically significant difference between the post-test and pre-test mean for each, the experimental group and the control group. We're using a dependent samples t-test rather than the independent samples t-test for this because the two means we are comparing will be generated from scores from the same group of people measured twice. So let's declutter here and get rid of our output window. And what we want to do first is tell SPSS that we just want to consider the control group first. And we can do that fairly simply by going into the data menu and asking SPSS to select the cases with a conditional statement. So in other words, we're going to input here in this box experimental group equals 0. So we're telling SPSS to select the cases if their code is 0 for the experimental group. In other words, we just want to look and analyze the data from those who are in the control group. And watch what happens to our data editor when we use this function. Get that out of the way. And you see it creates a filter variable that tells SPSS, yeah, I would like to use those with the code of 0 for experimental group, in other words, those in the control group, but I'd like to exclude those who do not have a code of 0, in other words, in this data set, those from the experimental group. And so you could see that represented in the filter variable, and you could also see that represented with the slashes across those individuals' records. So now let's compute the dependent samples t-test. We'll go to Analyze, Compare Means, And here SPSS actually calls a dependent samples t-test by an alternative name, paired samples t-test. And all it asks for here is to simply give the pair of the two variables you'd like to compare. So we have pre-test versus post-test site singing scores. And click OK. And similar to before, we have our summary descriptive statistics for the pre-test means for the control group and the post-test means for the control group. Remember, we're only dealing with half of the sample now, just 20 of the people rather than all 40. And these 20 people in this that contributed to this mean are the same exact 20 people that contributed to this mean. We also, by default, will get a correlation describing the relationship of the scores. And here you'll see there's a nice moderate positive correlation there, verging on strong, I'd say. And then in the paired samples test here, we have some, again, computations that SPSS does for us, the difference between the means, standard deviation, standard error of the mean, confidence interval of, of this difference, and then the t-value and degrees of freedom, and finally the statistical significance test of the comparison of the two means. And here we have not met the threshold of 0.05 or lower, so we would say traditionally that we do not have a statistically significant difference between these two means. In fact, we cannot reject the null hypothesis of no difference. So let's run the same thing now, but for our treatment group participants. So we'll go to Data and select Cases and reverse our code, so we tell SPSS to just consider those who are in the treatment group. And let's notice what happens in the data editor. Clean that out of the way. See the filter variable switches, and those who were slashed out before now are not, and those who were not slashed out before now are slashed out. They are excluded from analyses. And so we can go back then to Analyze, compare means, our paired samples t-test or dependent samples t-test, and we can just click OK again since this is already set up for us. And so here we have again the same default information, the summary of the means in the pre-test and post-test. This is for the treatment group now. The 20 people in the treatment group before the treatment and the 20 people in the treatment group after the treatment. The correlation between the two sets of scores, which is smaller than was in the previous analysis. The summary information of the actual t-test and our significance value, which compared to the previous result is pretty clear that we should reject the null hypothesis of no difference here, since the probability value, the sig value, the p-value is quite small. So it looks like the story here is that we have a difference in post-test means between groups, and we have a difference within the treatment group from pre to post-test as well, but no difference in control group from pre to post-test. And that's using SPSS for independent and dependent samples t-tests. Thank you very much.